Spearman rank correlation. A problem with the Carl Pearson method is that it may get fluctuated by the presence of extreme values, and moreover if we have the data which is in the just ordinal scale but not on the ratio scale, in that case it becomes and if the data is really in terms of grades which we call as qualitative data, in that case the application of Carl Pearson methods becomes a failure, and hence we use the case of what called as Spearman's rank correlation. So what is the major difference is that you can use this in both the situation. So we say it is only in the case of quantitative data, and this could be used both in the case of quantitative as well as qualitative. And statistics, as said, deals with there are very less techniques and tools available in the field of statistics which deals with qualitative data. And one such analysis is Spearman rank correlation. Now, how to decide in applying the methods? So you see first what is given to you as X and Y. So if you have purely quantitative data, and if there are no extreme values present in the data, then you can go ahead and apply the Carl Pearson correlation. Now, for most of the cases where you are obtaining the primary data, when you have done some survey, say you have taken X as time and Y as maybe the growth or the count of the bacteria per square centimeter which have been developed in the laboratory, and if you're looking into say age and IQ of the children or height and weight of the children, in most of the continuous variable which we observe, we, if the data is extracted using the correct mathematical and statistical ways, we try to observe less or almost no extreme values in such cases, and you can go ahead with the application of Carl Pearson correlation. Now, sometimes what happens is that though we have collected the data with great careful and utmost care, we may have the presence of that extreme value. Say if I want to talk about say X as the age of the car or the vehicle, and Y is the expenditure, or I could say the service charges or the maintenance cost. Sometimes, maybe because of some reason, though your values of the age of the car are admissible, like say 1, 2, 3, 4, 5 years, in some cases, maybe though you have a 3-year age car, because of some reason, the expenditure for that particular case could be 8,000 per month, whereas in the other cases, it could be say 2,000 or 500, 1,500, or a less value. So this could drastically drag your mean and standard deviation, so the correlation will change. So this was observed even by Carl Pearson, but all the methods he suggested are just based on mean standard deviation, and this person said that instead of using the original values, if you convert the given data into rank data by assigning set of ranks for both X and Y, indicated by Rx or Y or R1, R2 simply, then whatever may be the extreme value, however large it will be, the rank for that remains the same. So we apply the ranking technique for in the using the same logical order. So if you are assigning the rank from the decreasing order of the values of X, do the same thing for the values of Y also, and you get R1, R2, then using the ranks, you compute the correlation. Now, the method he uses is again the Carl Pearson method only, but instead of using X and Y, he use R1 and R2. Now, mathematically, we have obtained what will be the possible values of R1 and R2, how many are repeated or not. And by applying the Carl Pearson correlation, we have obtained the formula for the rank correlation, and that is indicated by RS, S for Spearman, or sometimes it is indicated by the Greek letter, which is called as rho. And the formula to compute the Spearman's rank correlation is 1 minus 6 sigma d square divided by n cube minus n, where d is equal to the difference of the rank R1 and R2. So as said, though we use the calculation method for R1 and R2, if I look into the possible ranks of n observations, and if you do x into y, x square, y square for R1, R2, like R1 into R2, R1 square, R2 square, and so on, and if you apply those values in the Calculation formula, that gets reduced to this particular form. So instead of using the columns R1 square, R2 square, R1 into R2, so just look into the values of x and y, assign the ranks R1 and R2, compute the difference of the ranks R1 minus R2, and then obtain the square of those difference, compute the total of that, divide that by n cube minus n, multiply by 6, and subtract it from 1. That gives you the correlation. Now, as said, it is completely based on the Spearman calculation method, and we know that calculation correlation always lies between -1 and +1. So the Spearman correlation also lies between -1 and +1. So when the data is perfectly correlated, that is your R1 is exactly same as R2, then your correlation will be perfect positive with value equal to 1. If you have R1 values, the extremes of R2, in that case you will have negative correlation. If R1 and R2, that is, the values are such that every rank comes to be equal to, such that the 6 into sigma d squared by n cube minus n is equal to 1. In that case, your rho can be take a value equal to 0. So it basically takes any number between -1 and +1. We say the correlation is high if it is close to -1 or +1. We say correlation is low if it is close to 0. So this is how the Spearman's rank correlation is obtained. Now, if you look into the advantage of this method over calculation, as said, it is highly preferable and easy to apply for the qualitative data also. And we talk about only those qualitative data. So whenever I say qualitative data, there are cases where qualitative data could be obtained in terms of nominal scale as well as ordinal scale. So nominal scale just talks about the presence or absence of the particular characteristics. Say if you're talking about gender, you can indicate male by 0 and female by 1. So if you are talking about, say, taste, an attribute which cannot be measured, so you could say indicate the various cases of taste, like say sweet by 1, maybe sour by 2, maybe hot or spicy by 3, and so on. So here, those numbers, say 0, 1, or this 1, 2, 3, they are just for the sake of representation, for the sake of identification. So that if you are collecting the data and if you are preparing the column for taste, and if you have observed the values like this, then in the table, 1 is indicating sweet, 2 is indicating sour, various cases. So you can't, say 1 plus 2 is equal to 3. So sweet plus sour is equal to hot. So that kind of numerical calculations are not allowed. And you cannot even say 2 is 1 times of that. You can't say sour is equal to twice sweet. You can't say that 0 is greater than 1, 0 less than 1 in this case, because 0 is indicating male, 1 is indicating female. So if you just look them as some numbers, mathematically, you can say 0 less than 1. But in this case, there is no logical order. So such method of extracting the data just for the sake of identification, we are quantifying them. Those are called as nominal scale. Now coming to the ordinal scale, so you can have again the numerical data, but the order could be given importance. So if I say high, medium, and low, and if I say 1, 2, 3, I can easily say 1 indicates larger value, 2 indicates the medium, and 3 indicates the smaller value. So the logical order has a meaning. So such type could be used, and that is the data arranged in an order makes some sense. In that case, we say the data is in ordinal scale. So even if you look into the uh, values like say grades given to the student, so you can have the grades like A plus, A minus, BC, So A has a meaning, B has a meaning, and you can arrange them in an order. So that has recorded over ordinal scale. So such data where the data is qualitative but recorded over ordinal scale, even for that data, you can obtain the correlation. So we'll see how to obtain this. And there are two cases of obtaining correlation. The above formula given is for the case where there is no repetition for x and y values. So if there are no repetitions within x and within y, we say the data is free of ties. So there are no ties in the data, but you could have repetitions between x and y. Some values of x could be repeated or observed in y and vice versa, but within x and within y, none of them are repeated. In that case, we say rho is equal to 1 minus x sigma d square divided by n cube minus n. But if there are some repetitions observed within x as well as within y, in that case, we say rho is equal to 1 minus 6 sigma d square, and we compute what called as a correction factor, and we use that correction factor in obtaining the correlation. So CF indicates correction factor. What is this correction factor? Since the values are taking the same numbers, different rankings cannot be given, but the number of observations and the maximum rank what we give, that must be same. So if I have say 5 values of x, I should give only 5 ranks for that based on the order 1, 2, 3, 4, 5. But if 2 values are repeated, I cannot give 2 different ranks. So I have to adjust them and take the average of the rank. Instead of 2 and 3, I can give the average of 2, 3, which is 2.5 and 2.5. So this is called as a correction thing, and that alters the formula of the Spherements by a factor of CF, where CF is given by m1 cube minus m1 by 12 plus m2 cube minus m2 by 12 and so on. So the number of terms will be the same, where your m1, m2, etc. indicates how many times a particular rank is repeated. So there will be various ranks, and there are possibilities that several values of x, several values of y could be repeated. So an x or a y has repeated indicates that the particular rank is also repeated. So if a particular rank, say rank 1 is repeated, how many times it is repeated, you call that as rank 1. So number of times rank 1 is repeated, number of times rank 2 is repeated, number of times rank 3 is repeated. So the first step is identification of how many values are repeated, how many times they are repeated. That gives your m1, m2. Substitute them here. That will fetch correction factor. Add that correction factor to sigma d square. So we'll solve 1 or 2 problems under this just to understand the method. But you need not worry. In the examination, we give you the simple problem, that is data which is free of the ties. Okay, so let us take a simple problem. We'll solve much in the practical classes. So I'll show how to assign the ranks. So let me take, say, marks of a student in 2 subjects. So I've selected the marks of 5 students in 2 subjects. Okay, so we have the values here. So just by looking into this, there are no extreme values. The suitable method is Carl-Pearson method only. But since we are learning the rank method, we'll see how to assign the ranks. Now, always there are 2 methods of assigning the ranks. You can start the assignment from the lowest value. In that case, use the same technique for both x and y, or use the highest value. And usually when we say rank, we mean that that particular candidate or that particular student has got highest marks, so that's why he has been given with rank 1. So we usually follow that pattern. So we usually assign the ranks in that order also. So even if you change the order, the final answer doesn't get changed. So the highest in the values of x. So first step you have to see that none of the values are repeated within x and within y. Between x and y, there could be repetitions that doesn't alter the result. Whereas in case of within x and within y, none of the values must be repeated. I said two ways. Either you start assigning the ranks from the highest value or from the lowest value. So I always stick onto this, the decreasing order of arrangement. So the highest value here is 22. So that particular marks takes rank 1. Now after 22, the next highest is 21. So it takes rank 2. Then you have 20 with rank 3. Then 19 with rank 4. And 18 with rank 5. Now similarly, when it comes to the values of y, highest is 30. So since I have arranged the ranks for the x values in the decreasing order, the same has to be considered for y. So ಇಲ್ಲಿ highest ಗೆ rank ಹಾಕ್ಬಿಟ್ಟು you cannot assign the rank from the lowest of y. So in that case, the correlation will be completely wrong. So this takes rank 1. Then the next highest is 28 with rank 2. Then we have 26, so it takes rank 3. 25, rank 4, and then 18 takes rank 5. Now, since there are no repetitions, we have rho is equal to 1 minus 6 sigma d square by n cube minus n. Please write the formula correctly. This n cube minus n is only for the denominator in the second term. Don't write whole divided by n cube minus. So I need to obtain the value of d, where d is obtained, d is defined as the difference between the assigned ranks. Now for every pair of R1 and R2, obtain R1 minus R2. So we have 3 minus 5 minus 2, 1 minus 4 minus 3, 2 minus 1, 1, 5 minus 3, 2, 4 minus 2, 2. And obtain the square of that. Now square of each of these values produces 49144. So when you obtain the sum, you will get sigma d square is equal to 22. So your rho becomes 1 minus 6 into 22 divided by n. N is the number of pairs of observations given. So that's equal to 5. 5 students' marks are selected. So this will be 5 cube minus 5. Now 1 minus 6 into 22. 6 into 22 is 132. 5 cube is 125 minus 5. So it will be 1 minus 132 by 120, which comes to 0.119. 1.119. One 32 by 120, 1.1. So this is minus 0.10. So the answer is close to 0 but negative. Therefore, we say the marks have negative and low correlation. Negative and low correlation. That is the conclusion. Okay. So we'll take a case where there are some repetitions in the x and y, and we'll learn how to assign the ranks there. So first is assigning of the ranks. Now, whenever you have repetitions, you have to assign the average of the ranks. So first we'll make a list of the value or the rank which is repeated, and then we'll see how many times they are repeated. So that is our m value, or let's say mi. Now if you look into the set of x, so you have the number 6 repeated 3 times. Now don't consider this 6 also, as if we'll just look how many different values have repeated within x and how many repeated within y. Now 6 is repeated 3 times in x, and when you look into y, you have the number 3 repeated 2 times and the number 8 repeated 2 times. So in total, in the given bivariate data, you have 3 numbers, 6, 3 and 8 repeated. So their ranks will also be repeated. The number of times a particular value is repeated, that will be taken as our m1, m2, m3. Now only 3 values are repeated here, therefore I'll have the terms up to m3 in the correction factor. Now correction factor is defined as m1 cube minus m1 by 12 plus m2 cube minus m2 by 12. And since I have m3, it will have 3 terms, that is m3 cube minus m3 by 12. Now when I have m1 here is 3, so this will be 3 cube minus 3 by 12. 3 cube is 27, 27 minus 3 is 24, 24 by 12 is 2. And when you have m is equal to 2, it will be 2 cube minus 2 by 12. 2 cube is 8, 8 minus 2 is 6, 6 by 12 is 0.5. So these two each are 0.5. So the correction factor comes to a total of 3. So this is how you obtain the correction factor. So list out how many values are repeated, how many times they are repeated. The number of times a particular value is repeated, that will be taken as m, and see how many such m's could be obtained from the table, and obtain the same number of terms in the correction factor, substitute the value of m, obtain the sum of those terms. Now the next step is assigning the ranks. Now what you have to first do is you just put the ranks as you did in the previous case, and then select where the values are repeated, and those two cases will be averaged. Now the highest value here is 1, and the next highest is 8, so that takes rank 2. Next I have 3 values, that is 6, 6 and 6, and the respective ranks will be 3, 4 and 5. So there are 3 possible ranks given for this number 6, which are 3, 4, 5. I cannot give those 3 different ranks. So what I do is I put the average of these values. Now when I say average of a set of numbers, it is arithmetic mean, and that is given by sum of the observations divided by number of observations, and the average of 3, 4, 5 comes to 4. So each of these 6 will be given the rank 4. So this 4 is indicating all the 3 ranks, which are 3, 4 and 5. So the next rank to be assigned in the column will be 6, and that is for the next lowest value, which is 3. So are you getting? So first write all possible ranks for that number and then take the average. Now coming to the case of y, highest is 8 here. So I have to put the ranks 1 and 2 for the number 8. The average of 1 and 2 is 1 plus 2 by 2, which comes to 1.5. So both these numbers 8 will take the rank, average rank, as 1.5. Next, the next highest after 8 is 7. So I'm done with the rank 1, 2. So the next rank in the list is 3. Then this takes rank 4. And then I have 5 and 6 for the number 3. Average of 5 and 6 is 5.5. They take the average ranks. Now, if you look into the repetitions in the ranks, whatever the number of repetitions you have for x, the same number of times the rank will also be repeated. So that's why I say either you look into the value which is repeated or the respective rank which is repeated. So 3 is 5.5 and then 1.5. So, but these values are not required. What we need is how many times we have repeated. So now compute your d and d square. Obtain the total of d square. We have 2 minus 3 minus 1, 4 minus 5.5, 1 minus 5.5, 4 minus 1.5, 6 minus 1.5, then 4 minus 4. Obtain the square. So the total of d square comes to 26, 46, 47, 48, 49, and 50. Now substitute them in the formula of rho. Rho will be 1 minus 6 into sigma d square plus Cf divided by n cube minus n. So this will be 1 minus 6 into 50 plus correction factor 53 divided by 6 cube minus 6. So this becomes 1 minus 50 plus 3 is 53. 53 into 6 comes to 318. And then 6 cube minus 6. 6 cube is 260. 216 minus 6 is 210. So we have the value of rho is equal to 1 minus 318 divided by 210, which is 1.5142 minus 0.5142. So we have a negative value and the answer is close to 0.5. So we say the correlation is negative and moderate. Negative and moderate. So whenever we have correlation value close to 0.5 or minus 0.5, we say it is moderate. Tumba low illa, tumba high kuda illa. That's the interpretation. Okay. So any doubt here in assigning the ranks?
No, sir.
Time ಬೇಕಾ ಬರ್ಕೊಳ್ಳೋಕೆ ಆಯ್ತಾ? Okay. So this is about measurement of the correlation. So here we only looked into what called as the qualitative data. Now there are certain times which are the values like say the nominal scale data. So as said, our gender is indicated by 0 and 1. Now at certain times, doing the research, we want to come across say correlation between say blood pressure and gender or blood pressure and some other variable. So you can indicate or take the values as 0, 1, or you can indicate male by 1 and female by 0. So such data are called as categorical data. So just to categorize the properties, you are using the symbols. Instead of using symbols, you are using the numbers over there. So even for such data, there are methods of obtaining the correlation. So many such cases are there, but here, as per the syllabus, we have only Carl-Pearson and Spherements correlation. So we'll not worry about the other cases of data as well as their types of analysis. Now, moving ahead into the next case of the analysis in bivariate data. So as said, first we study what we study and we try to answer the question where we say whether there is any relationship between my x and y, whether there is any relationship between x and y, and that question is given by the correlation. So yes, there is correlation, no, there is no correlation, and if I say yes, the correlation is high, and then I could go ahead and find out what exactly is this f of y. Or if you are modeling in a case where you say y is dependent on x, then we try to obtain the function. What exactly is this f of x? And as said, moreover, we are interested in obtaining the linear relationship between x and y. So we try to obtain a linear relationship or linear function for f of x and f of y, and that is called as regression analysis. So what is this regression? Regression, it simply means, using average or moving towards average, regress, right? Go backwards. So we have used the concepts of average, standard deviation in building the or answering the question whether there exists any relationship between x and y. Now using the same concept of average, we try to obtain the mathematical form of that particular function. So the equation of regression has to be obtained. And since we are dealing with the linear case, we talk about equation of the linear line. So usually that will be a straight line because we are talking about simple correlation and cases like that. So what exactly is a regression line? So we have learned how to plot the scatter points, scatter plot for various values of x and y. And at the time of deciding whether there is correlation, I told you just try to imagine a straight line which is as close as possible for the points. And this line, what you imagine or what you draw, that is called as regression line. And that has to be mathematically obtained. And whenever I say we are talking about a straight line, the form of the straight line will be y is equal to mx plus c, where m indicates the slope and c indicates the y-intercept. So we have to obtain the values of m and c, and to obtain that, we use the concept of average. So we have, come away from the average, the concept of average, and we looked into various other analysis. Now we are going back to that particular concept of average in order to obtain the regression equation. Now, if you have a scenario like this, where we are telling that y is a dependent variable on x, that is, you can control the values of x such that the values of y changes, or I could say y is purely dependent on x. In that case, this equation is called as regression line or regression equation of y on x. So what I can do with this line is that I could suggest any particular value of x, say this value, which is exactly on the line, and I could see what is happening to the value of y. That means for any missing value of x or for any future or the new value of x, I could easily obtain the value of y once I know the regression equation. And this method of estimating the value of y works very well whenever your R is very high. So if you have high correlation between x and y, and if I have come up with the regression equation, then that regression equation could be easily used in estimating the missing values of y or new values of y for a specific value of x. Now, if you swap this x and y axis on the same data, now the relationship is interchanged. So now you will have the points like this. So I have interchanged them. So this will be my y, this will be my x. So if you look into the equation again, possible equation closer to this, then this is talking about the relation x is equal to f of y. And here we call this function as regression line of x on y. Now, whatever may be the case, you can try to combine them. So instead of plotting x versus y or y versus x and then seeing the relation in the same scatter plot, you could try to build the other regression line such that it is possible, or the other possible line which could be drawn such that the error is less. Now, infinitely many such lines are possible. So if you have a set of points, you can decide many such possible lines which passes through most of the points which are closer to that. Out of the two cases, we are obtaining two equations, two straight lines which could be obtained using the means and standard deviation, and those two are called as regression lines or equation of regression. There are two cases. The first one is regression line of x on y. So when I say x on y, I basically am finding an answer for f of y. What is the function f of y? And that is given by the equation x is equal to bxy into y minus y bar plus x bar, where x bar and y bar are means. Bxy is given by the formula r into sigma x by sigma y. That is standard deviation of x and standard deviation of y. If you know correlation and standard deviations, or if you don't know that particular information, but some raw data is given, in that case your bxy will be n sigma x minus sigma x sigma y divided by n sigma y square minus sigma y whole square. And this is called as regression coefficient. When I